name is Srikar, and welcome to Montville Math. Here we will be discussing completing the square. So to help you learn complete the square, we have to start off with an example, and I'll explain as we go on. Excuse me, thank you. So the example we'll start with here will be x squared plus 5 over 2x. Actually, no, let's just keep it at 5x. Plus 6 equals 0. So that's our starting quadratic. Before we complete the square, we have to prepare the quadratic first. First, you have to see if there's a coefficient on the left-hand term, the x squared term. If there is a coefficient that's not 1, you have to multiply the reciprocal of that coefficient to make the coefficient 1, because that's the goal, and multiply everything by that coefficient. So that's good. So now, there's 2 steps to prepare the quadratic. That's the first step. We don't have to do anything because the coefficient's 1 on the left side. The second step is to move the constant to the right side. So you get x squared plus 5x equals -6. Perfect. Now we're going to actually complete the square, and this is the hard part. You have to make a separate corner over here. Sorry, it's a little confusing. So basically what you have to do is first you have to take the term of the middle plus 5, the term of the x to the 1 power, which is plus 5 in this case. So what you have to do is divide that by 2. So that'll be very important, and then you also have to square that. You have to circle this, and then you have to circle 2 terms, both of which will be convenient, and then the square of this. 25 over 4, perfect. Okay. So now you just have to add the second term, what I wrote. You have to add over here, and what you do to the right side, you add to the both sides. So you add to the left side, I mean. Okay, so it's x squared plus 5x plus 25 over 4 equals -36 over 4 plus 25 over 4. You saw nothing? Okay. So what we did here was we added 25 over 4 because it will prove useful into actually making our square. And what you do to the right side, you do to the left side, and don't make a computation mistake like what I did. Okay, so now the square, we have to use the second term that we have here. So x plus 5 over 2 whole squared equals 1 over 4. So now, since we have 2 square terms, what you do to the right side, you do to the left side, and conveniently that rule will help now. So just take the square root of both sides, because what you do to the right side, you do to the left side. X plus 5 over 2 equals, whenever you take the square root of something, it's plus or minus, like the square root of 1 is plus or minus 1, like -1 times -1 is 1. So that's useful, equals plus or minus 1 over 2. Okay. Now, finally, isolate x. This should be relatively easy. Equals -5 over 2 plus or minus 1 over 2, or that'll be, so -5 over 2 minus 1 over 2 equals -6 over 2, which is 3. -5 over 2 plus 1 over 2, is negative 4 over 2, and that is, this is negative 3, sorry, is negative 2. So the answer here is equals negative 3, negative 2. So there you have it. Let's continue with another example. This one even more interesting. For the next example will be really useful because it'll help you complete the square for all quadratics. By all quadratics, I mean all quadratics. Whether it be x squared plus 2x plus 1 equals 0, x squared minus 245x plus 3 equals 0, x squared, 2x squared minus 341x plus 3 equals negative 4. It could be anything. So this quadratic will help you solve x for every quadratic. And the starting equation to help you find x for all quadratics is the definition for quadratics, which is ax squared plus bx plus c equals 0. You might say, hey, there's a coefficient in the first x term, it's in the x squared term, it'll be a little tough. It will be a little tough. Excuse me, sorry. Okay, so ax squared plus bx plus c equals 0. Let's prepare a quadratic as we usually do. So you first divide by the coefficient of the x squared term, which is a. So x squared over a plus bx over a equals negative c over a. And we're saying, when we're doing negative c over a, is because we're doing both steps in one shot. Ax squared plus bx equals negative c, and then you divide everything by a, or you could do vice versa. You'll get x squared plus x squared over a plus bx over a equals negative c over a. So now we can actually start completing our square. Sorry for my bad handwriting. We have to do that thing on the right. It may have been a little confusing last time, but I hope it'll be all clear now. So we have b over a, right? So, okay, so we have b over a, right? So we have to divide that by 2, which will be b over 2a. And we have to square that. We're going to use the square term first, remember that. You circle this one, and then circle the next one. You could put a little 1 over here and a little 2 over here to remind you do this first and you do this second. I'll do that right now for your convenience. So first you divide this by 2 and then you square that, and b squared over 2a. You have to whole square this, remember? So b squared over 2a squared will be 4a squared, because you have to square the 2 as well. Okay, so now x squared over a. Oh wait, I just realized. It's not x squared over a. It was ax squared divided by a. That's just x squared. Sorry. Thought this thing looked weird. Okay, so x squared plus bx over a plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. Okay. Now what we're going to do is we're going to take the square root, we're going to convert this into a nice simple square using our second box term, or circle term, whatever. So that'll be x plus b over 2a whole squared. And the reason we're doing this is because if you expand this, it'll be x squared, right? Plus 2 times b times x divided by 2a, which would be b times 2, which would be bx over a, because that's how it works. And if you square this, you get b squared over 4a squared. I'll expand it for you in the end to make it clear, but okay. So now minus c over a plus b squared over 4a squared. Okay, that's a mess. Let's clean it up, at least to an extent, in which it'll be much easier to take the square root. So multiply both sides of negative c over a by 4a. It'll work out in the end. So equals, oh no, put the b squared term in the beginning because commutative property of addition or associative, I can't remember, but b squared over 4a squared equals minus 4ac over 4a squared. Now we can take the square root of this mess, which will be x, you take the square root of this and you take the square root of this. So x plus b over 2a equals plus or minus the square root of b squared minus 4a squared all over, and you plus or minus because of the, I explained why you do the plus or minus in the previous example if you're just tuning in. So you take the square root of both sides. As we saw, 2a whole squared is 4a squared, so the square root of 4a squared is just 2a. Now we just have to isolate x. X equals, and since the denominators are the same, we could just do negative b plus or minus the square root b squared minus, excuse me, sorry. You know what, I'll just write that over here. X equals from there negative b plus or minus the square root b squared minus 4ac all over 2a. So I hope now you learned how completing the square works. And also, the cool thing about completing the square with this particular equation is that your final answer, right? If you know what A, B, and C are, you can just plug it in. I'll give you a couple seconds for all this to sink in, or you can hit the pause button because I accidentally rushed the last example. Okay? Good. Now, I'll explain this weird step, which you're probably wondering, why are you doing this? How on earth does, maybe not how on earth, but how does x plus b over 2a whole squared equals x squared plus bx over a plus b squared over 4a squared? Like, doesn't seem to make a lot of sense, so I'll do it in this corner right here. So, x plus b over 2a, which is our second thing we use right here, whole squared equals x squared plus, so 2 times b over 2a times x, so that's 2 times 2 2 times b over 2a times x. 2's cancel. You get bx over a, which is our middle term. So x squared plus bx over a plus, and you square this, b squared over 4a squared. Okay, so that's how completing the square works, and I hope we've explained every part of it. Thank you. Please like, comment, and subscribe, and have a good day.